on through literature review, it was found that orange peels are composed of 98% of D-limonene, which is also commonly found in organic cleaning agents. Thus, our group strongly believes that D-limonene is a component in orange peels that cleans. Hence, the main objectives of the project now narrow down to determining the extraction protocol of D-limonene that best extracts the highest yield. The first method of extraction that we tried was cold press, which is one of the industrial ways to extract D-limonene. However, because we don't have those excessively large machines, we did it in a more small-scale manner. Firstly, we tried to use garlic press to squeeze the orange peels to force out the rinds. However, it was tedious, time-consuming, and produced very little yield. Therefore, we invented our own cold press. Yeah, as you can see over here, this is the cold press that we made. The box here, we will put the peels inside, and as you can see, there are many holes to allow the orange oil to run out. Okay, we're going to cover it up and then use an F-clamp to force and compress the orange peels so as to force out the oils. However, this cold press that we invented did not exert enough pressure, so we didn't manage to extract any oil. Therefore, the cold press method failed.
Now I'm going to talk to you about steam distillation, which is the second method that we have used. It is the most effective way to extract D-limonene. And although the common ways of quantifying D-limonene are through the use of a gas chromatography or through the use of a mass spectrometer, the group decided to explore the use of a HPLC to quantify D-limonene. It is an alternative given by the resources that were available to us. Also, instead of comparing the use of D-limonene against a pure D-limonene standard, the group compared the D-limonene against a DL-limonene standard because the group wanted to explore something different with what sources were available to us. In this experiment, the conditions for steam distillation were varied. More specifically, the group tested the influence that adding salt to a distillate had on the use of D-limonene extracted, because according to literature review, salt increases the ionic strength of water and enhances the separation of oil from water. As mentioned, this was done by quantifying the amount of D-limonene present in the distillate using a HPLC machine. So I will now pass on to group member Roy, who will elaborate on the results.
Now I'll share with you the results. Based on the results obtained, the distillate that had salt added to it produced a higher yield of D-limonene as compared to other distillates which did not have salt added to them. This is evident from the graph here. In fact, this was indeed in line with the theory behind adding the salt, that salt does enhance the separation of oil and water.
Now I'll be moving on to the discussion. In this experiment, one limitation that we faced was that the HPLC results showed that the DL-limonene standard was not pure, and one possibility for this would be that the DL-limonene was overly exposed to air having been stored for a long time and exceeding the shelf life of DL-limonene. Literature review states that limonene rapidly oxidizes in areas from carbonyl and carbon, which are the two possible identities of the impurities reflected in the HPLC printout. Here is a snapshot of the HPLC printout, and as you can see, there are two major peaks at 18 minutes and 28 minutes respectively, and both of which do not coincide with any of the peaks of our samples. So we believe that these are carbonyl and carbon. And as you can see here, at 1.246 minutes is a peak that coincides with all of the samples of our distillates. Also, in order to further determine the protocol of steam distillation that best extracts the highest yield of D-limonene, further research can be done to examine the influence of the concentrations in the puree, as well as the volume of water added to the puree in the distillation flasks on the use of D-limonene extracted. In conclusion, the orange peel is the most effective part of the orange that acts as a cleaning agent against tannin stains. And meanwhile, steam distillation is also a more effective method as compared to cold press. And thereafter, adding salt to the distillate in steam distillation also serves to produce higher yields of D-limonene.
Thank you.